Hello friends, in this short video I'm going to be talking about triangles. Triangles are a very important shape in geometry, so it is crucial that we know the different kinds of triangles that exist and ones that we can make. Before I talk about the different triangles, I just want to point out a couple of aspects of this tool that I am using. Now, as we know, a triangle has three sides to it. The lengths of those three sides are labeled here, here, and here. Now, because a triangle has three sides, this means that it also has three angles as well, which are displayed right here, here, and here. What's awesome about this tool that I'm using is that I can only control point C right here. I cannot control point A and B. Those stay where they are. But just by controlling C, I can really form whatever triangle I want to make. And if you notice where it says from its sides to B and from its angles to B, whenever I move point C, the labels are constantly changing. It's pretty incredible, isn't it? So, as you can see here, I have a scalene obtuse triangle. What is that? Are they two separate things? Are they the same? Well, different kinds of triangles can be formed from its sides, or labeled as from its sides, or its angles. So we have a scalene obtuse triangle. So even though they are two separate things, when brought together they form a triangle like this. I'll show you another example of a scalene obtuse triangle. So we have another one right here. Now, let's talk about sides first. There are three different triangles that can be formed from its sides. So, first I'll show you a scalene triangle. So, a scalene triangle is one where all three sides are different lengths. We have 5, 3.7, and 5.5. These are all different lengths, as you can see. Now, I'll show you the next triangle that can be formed from its sides. Now, what do you notice about the three sides now? What do you notice about them? Well, two of its sides are the same length, while another is different. Two of them are 5, while another is 5.5. That's because an isosceles triangle is a triangle where two of its sides are the same, while another one is completely different. Lastly, I'll show you what an equilateral triangle looks like. So, what do you notice with the sides now? All three sides are the same length. Every single one is 5. What's also very interesting is that look at its angles as well. All three angles are exactly the same. All three of them are 60 degrees. So keep this in mind. Now, next we'll talk about angles. Similar to its sides, three different kinds of triangles can be formed from its angles as well. First, we will talk about right triangles, which is a really good place to start when talking about angles and triangles. Now, a right triangle is a triangle where one of its angles is exactly 90 degrees. Does not matter what the other two are. Do you notice that this angle, or this corner, looks like it could be part of a square? Well, that's because a square, if you imagine it, all four of its angles are 90 degrees. So when thinking about right triangles, think about putting a piece of paper where this angle is, or putting a square where this angle is. The two lines, the two sides here, are perfectly perpendicular to each other, which creates this 90-degree angle. So keep that in mind. Next, we have an obtuse angle, which is what we have right here. Notice point B from just earlier, that was 90 degrees. What do you notice about it now? It's a lot larger, isn't it? It's 127 degrees. An obtuse angle is one where any of its angles or one of its angles is greater than 90 degrees. I'll show you another example. So as you can see, point A this time is 126 degrees. It does not matter what the other two angles are. Only one of them has to be greater than 90 degrees. Lastly, I'll show you what an acute angle looks like. So, what do you notice about the three angles? All three of them are below 90 degrees. An acute angle, or acute triangle, is a triangle where all three of its angles are less than 90 degrees. I'll show you another example. It does not necessarily matter on size at all. In fact, I can form big acute triangles, and I can form small obtuse triangles. So size doesn't normally play a factor at all into the angles of a triangle in terms of what you would label it. So let's go back to our scalene obtuse triangle from earlier. So if you remember, what is a scalene triangle? It's a triangle where none of its sides are the same length. Along with that, we also have an obtuse triangle at the same time. Because, look at the angle right here, 135 degrees, right at point B. So we have a triangle right now that's a scalene triangle and an obtuse triangle at the same time. So when labeling triangles, almost pretty much all the time you'll have something that affects what its sides are and what its angles are. I'll show you another example. So right here we have an isosceles acute triangle. Do you remember what an isosceles triangle is? Two of its sides are the same, while another one is different. It's also an acute triangle. So three of its angles are different. We have 75 degrees, 53 degrees, and 52 degrees. So I really hope this video helped a lot with labeling triangles and what they are in terms of its sides and its angles. If you have any questions for me, please ask me during math class tomorrow. Thank you very much. Have a great day.